Good morning, everybody. Let's go back to this gradebook class in Java. Gradebook is a very simple class. If we draw the UML diagram of this class, it is simply class. In its private section, I have a course name, and its type is string. And of course, I have my constructor, and I have my set and get methods, and I have my display message method. Okay, display message. So that's it. This is the gradebook class, and let's see how it is implemented. The constructor, okay, so inside the class there is this string. And question for you, what kind of data member is this string? Private string course name. I mean, it's an object, or it's something else. Is course name an object?
Yes.
No, the answer is no. It's not an object. Course name is what? What is course name? Course name is a string what?
Instance variable.
Yeah, it's an instance variable, but what kind of instance variable? Course name is a string what? Oh, good. You think about it, I am coming back. Yani şu iki tane yaptım bundan en sonkinden. Sözleşmeden 3 tane yaptık da diğerlerinden şu. Taahhütname ve muahhütname. Bunlar da bunlar. Hepsini tarafladı. Aynısını takdir ederseniz herhalde. Topların gerisi sizde. Nasıl bir şey bağlıyoruz böyle.
Bundan sonra elektronik ortama taşınıyor da bu kadar zahmetli çok.
Tamam. İyiydi de bir. Tamam. Geçen seneki burada da tamam. Çok iyi yapmışsın.
Başka hocam yok mu böyle?
Efendim?
Başka bir şey yok.
Şu anda kötü yok.
Ne diyeceğim? Ankara'dan arkadaşlarla konuşmak istiyorlar. Ben bir posta yapacağım size tanıştırmak için.
Ne konuda?
Hiçbir fikrim yok. Sadece sizi görmüşler ve bu hani size şirketin vesairesini.
Esasında Havelsan'la bir takıntımız var o konuda. Havelsan bu sağlık işlerine girmeye çalışıyor ya. Biz onlarla falan şey yaptık. Olur mu? Görüşelim tabii.
Bunlar şey tarafında, simülatör tarafında. Sağlıkçılar
Öyle mi?
tarafında var.
Evet. Tamam, olur görüşelim tabii.
Tamam, ben bir tanıştırma mesajı atıyorum.
Bizim şeye ihtiyacımız var. Paraya. $1 milyon lazım.
$1 milyon.
Almanya'da 3 kişi çalıştıracağız. Amerika'da 2 kişi çalıştıracağız.
Dolar diyorsunuz. Yani bir yurt dışı olsa.
Bir zahmet.
Tamam, şimdi teşekkür ederim.
Görüşürüz.
Kolay gelsin.
Okay, so what's your answer? What is?
Can you see the chat?
No, I can't. Of course I can't. What do you mean?
I mean, there are two answers in chat.
So you read it. The last time I see it, it is good morning. We will start at 8:45, and that's me.
Okay, Anılmer says data member. Mustafa says it's field.
Yeah, it is field. It is not data member. We know that, but what kind of a Java thing it is? Well, let me tell you. I don't know how to ask this question, but course name is not an object. It's a reference. Okay, it is not an object. In Java, we don't name objects. Okay, we will not have any names for objects. For example, when we start using this gradebook. This gradebook one is not an object, it's a reference, okay? We create object like this. Okay? And we hold a reference to it. This is exactly the same, okay? You cannot keep objects in your classes in Java, period. Okay? There is no way. You cannot hold objects in your Java classes, Java objects. Okay? At most you can do references. Okay? At most you can do references. That's what I'm saying. Okay? Why am I insisting on this? What is this and what is the reference and kind of thing? That's going to become clear in a few minutes. Okay? Let's look at the constructor. What does the constructor do? It will take a string reference name and it will assign this to course name. Okay, let's talk about line 11. What kind of an assignment is line 11?
Reference copy.
It's a reference copy, right? Exactly. Who said that? Enis. Yeah. Okay. So when you say reference copy, you kind of felt bad, right, Enis? Why do you feel bad about this reference copy 11? I mean, as a C++ programmer, this sounds weird because what? I mean, you see the trouble that you're running into, right? Something bad is going to happen at line 11, after line 11. Why? What is wrong with line 11? As a C++ programmer, you think about it. We don't do that kind of stupid stuff in C++. This is so...
because a string has character pointer.
Yeah.
We assign it directly.
Uh-huh.
If name is modified,
Yes, exactly.
and course name will change.
Yeah, exactly. So, did everybody get that? Let's go to the code, client code. I make a new gradebook, okay? But in this case, I was lucky because I used a constant here, but let's say I have another string. Let's say I used another string. Let's say my name. I sent this my name. My name is a string. I have created it before. Okay, let me create it. Okay, string my name is new string a. Its initial value is this. Okay. Okay. So I sent my name to Gradebook and Gradebook constructor okay, Gradebook constructor took this my name and it assigned it to course name. So now I have my course name in it, but I am pointing to the same string, and when I say get course name, it will return my name. Okay, this ABCD. When I print display, okay, print message, it will do that. But how about this? After line 11, line 13, I do this. My name index operator 5 is x. Okay, I am changing the fifth element of that string to x. Isn't this going to mess up my gradebook class? Okay, so that's bad, right? I mean, as a C++ programmer, this should not happen. What kind of a stupid mistake is that? I mean, I told you that these Java designers are very smart C++ programmers. I said that, right? That's right. So how come they are making this mistake? Does anybody know the answer? Is there anybody who knows Java? I think some people know Java. Some people know Java, and maybe the graduate students. Somebody raised hand and they okay. Well, does anybody have the answer? Does anybody have the answer?
I think with the constructor, we don't have reference parameter. Because of that, my name 5 is x is not modifying gradebook name.
But we did not copy, we did not make a deep copy, right? All we did was the memory is like this. Memory is like this. Okay, I'm going to show you the memory. My name is a reference and it points to A, B, C, D in my memory. And then I have my gradebook 1, it points to the same string inside it. Okay, so this is the picture. This is exactly the picture. This is not wrong. If you look,
String is const.
we didn't say anything const about string, but what you are saying is correct actually. In Java, okay, this is kind of a shocking maybe. String is a immutable class. You cannot change a string once it is created. Nobody can change it. In string class, there are no indexing like that. Okay? In string class, there are no indexing like that. In string class, once the string is created, you cannot change it. It is designed that way. It is not like C++ strings. Okay? So that's how they solve this problem. Well, maybe that's a solution for string objects, but how about the other objects? Well, for the other objects, you need to be careful. When you make a copy, you need to make a deep copy, okay? When you make a copy, when you make an assignment, you know that assignment for objects are reference assignment or value assignment, okay? Reference assignment or value assignment, that kind of stuff. So that's kind of the solution. So you design your classes in a careful way, then you can avoid making deep copies or writing extra code. So let's go back. So that's what happens. Assignment means value assignment in C++. There is no copy assignment. Okay, if I have an integer I and j, when you say I, guess the value of j. The value of j is assigned to I. If you have two strings s1 and s2, when you say s1 guess the value of s2, okay, this is a reference assignment. Both of them are now pointing to the same string object in my memory, somewhere in my memory. Okay, assignment will never do deep copying for you. Okay, if you are gonna do deep copying, there are other solutions and we are going to see it. and it is kind of detailed, and we need to talk about it a little bit more. Okay, so seemingly at the beginning, I mean, if you are introduced to Java, okay, when they talk about this assignment, I think I spent time is like, okay, I spent maybe 10 minutes talking about this assignment. They don't spend that much time. They just say this is assignment, reference assignment, maybe at most. So when it comes to deep copying and that kind of stuff, then they need to go to more in details. But most Java programmers, to be honest, they don't know what deep copying is. Okay, because I mean, what was the idea of Java? Keep it simple, don't make any mistakes and that kind of stuff. But if you want to do some detailed programming, okay, the programming that involves this kind of stuff, then you need to talk about references and pointers and the memory location and etc. And if you don't know the pointers and if you don't know how the memory is managed, it is not that easy to understand that kind of stuff. Okay, so my feeling is, if most people, most Java programmers, I am not saying all of them, okay, they live their lives without knowing these kind of details, and that's okay. That's okay for most of them, because all they do is doing some straightforward application development. Okay, so setter is the same thing again. Reference assignment. Getter, no problem. And again, we don't have this const stuff here, okay? And that's kind of bothers me. Why? Because this one is not going to modify the object, but it doesn't say const because we don't have const keyword in Java, and we don't have anything similar to what we do in C++. Okay, so what you're gonna do? Okay, what you're gonna do? I mean, if you are afraid of somebody modifying your class objects and you don't want them to, what would you do? This is what I would do. That's what Java says. Don't write this then. Okay, don't write it. Don't write set course. Okay, and you will be fine, because set course is the only method that modifies your course gradebook class, right? Don't write it. But what happens if I want to change the name of the course? Well, in that case, write another class, another gradebook class. Do this, okay? Okay, you know object-oriented programming. You do this. Gradebook of an immutable or unmodifiable gradebook. In this gradebook, of course, I have my string course name, and I have my constructor I have my get course, and I have my print message. And then you drive another class. Okay, of course this one doesn't have any data members, and all it has is everything is the same. I have my, what is the name of the class? It is gradebook, but this one is mutable. You have your gradebook mutable constructor, and you have your set course name. Okay, so you add this set course name here. So if you don't want anybody to change your objects, then let them use this class objects. If you like your class objects to change, and then you would use this one. Since there is an is a relationship, if a function needs a gradebook you can send a gradebook modifiable to that function, right, or method, because there is an is a relationship. So this is a more general class. This is a specialized class. All the mutable objects, gradebook modifiable mutable objects, are gradebook unmodifiable objects, right? Okay, so that's the solution. That's the solution if you like to do that. Okay, and in fact this is even better solution than using the const keyword, because the difference between these two are mutable and unmutable. Maybe you like to make other kind of differences, like incrementable gradebook, or settable gradebook, unsettable gradebook. So you could put different features on it, and you can drive anything you like, but you don't have the const keyword. Okay, so I think this is smart. A little bit more coding, but you can achieve the same effect, and you can achieve even more. String is a class like that. Okay, string is a class that is not modifiable, and I am not sure if somebody derives from string. Let me try to find the documentation. Java class string from the Oracle side, Oracle pages. Let me find the Oracle pages. Okay, so the string, these are the stuff. Anybody derives from string? I don't see it. Look at all these methods. No, I don't see it. So they did not do that. Oh, okay. String builder. String builder is a string class that is modifiable. Okay, or string buffer maybe. It's a modifiable string. But let me see if it derives from. No, it doesn't come from string. No. Okay. So see, I like this sentence. A string buffer is like a string but can be modified. But they didn't use the is a relationship between them for some reason. I'm sure it's a good reason. Okay. So this string buffer has lots of stuff like appending it. Okay. Point code, point character at. By the way, there is no, for any string or for any object type stuff, there is no indexing operator. Indexing operator is not there, okay? Even if it is mutable or anything like that, okay? Index operator is not valid for any objects, because in Java, okay, hold on to your seats, I am going to tell you something. Maybe you know about this, okay, you will be shocked. In Java, there is no operator overloading, okay? So it is easy to get a passing grade from a Java course, because one less chapter is good, right? So there is no operator overloading in Java. You are not allowed to overload the plus operator and that kind of stuff. Because when they introduced this idea of C++ programming, they say that all the new classes are going to behave as like my old classes. So if you have a money class, it will behave like an integer class. So if plus is valid for integers, it's going to be valid for the money too. And that was the idea. So I will treat all of my objects like the same. Doesn't matter if it's integer or money. That was the thing. So they added this operator overloading. After 10-15 years of hard programming with C++, they realized that not many people are using the plus operator or minus operator, and it is making the language complicated. And I have all this Java virtual machine. I like to keep it simple. So they got rid of the operator overloading from Java. Okay. And then you may ask, if operator overloading is not that useful, why did you spend like 3 lectures on it? Okay, we did it because when I teach you about operator overloading, there are many things that you learned other than the operator overloading, like the necessity of references, okay, memory stuff and that kind of stuff. Remember the partially filled arrays? We started doing that in the partially filled arrays, right? So I like operator overloading in C++ while teaching C++ because it lets me talk about object-oriented programming in C++ a lot. Okay, but in Java you don't have the operator overloading. Okay, so let's get rid of this stuff here. Let's look at this code. Okay, so there are mutable classes, unmutable classes, and Java design philosophy of Java is that. Okay, this is object serializable character sequence. You don't know what these are yet, but these are something beautiful and you're gonna see why. Let me see if I have the string. What does the string says? String comparable character sequence. Okay, so it comes from character sequence. String class represent characters. Where is unmutable stuff? Yeah. Because string objects are immutable, they can be shared. You don't need to make deep copies of string objects. And in fact, try to use this idea in C++ too, okay? If you make your class objects immutable, then you can share them. You don't have to make deep copies of them. Okay, just share it. Just share it. You don't have to make deep copies of them. Okay, good. And that would work very nice with the shared pointers, because many shared pointers are pointing to the same immutable object. Nobody's making a copy, and the last shared pointer dies, your object goes away. So that would be very efficient programming. Okay, good. So Gradebook test makes two Gradebook objects on your heap. Okay, it will make two Gradebook objects on your heap, and it will call get course name on both of them, and it will use this printf, our good old printf method, and it will give you the results like that. By the way, in Java, if you, instead of doing this, okay, instead of writing this, if you say, let's say, not S, but maybe let's say D, okay? If it needs a integer, but if you send a, let's say, string, the compiler will not compile this, okay? Compiler will say that these two types do not match, okay? So remember the behavior of the printf in C, it didn't do this kind of stuff. I mean, during the runtime, if we are lucky, we would get a segmentation fault. If we are not lucky, we will get some junk on our screen, right? In Java, this will not compile. So it is a much type conscious language than C and C++. Okay, any questions so far?
Hocam, you said there is no operator overloading, right?
Yeah, well, you don't believe it, but yeah, believe me, yeah, there is no operator overloading.
Yeah, it's really kind of shocking. But how do we use copy assignment operator? I mean,
There is no copy assignment in Java. All the assignments are value assignments, okay? I mean, if you are assigning, let me go back here. If you are assigning two primitive types like this, that's the integer assignment and double assignment. If you are doing an assignment between object references, it's a reference assignment. If you are asking me how you do the deep copying, there is a way of doing it, but I need to deep copying is kind of advanced Java programming technique, and it is usually talked about maybe at the end of the semester, maybe the second semester. They don't talk about it at the beginning, because I need to be able to do deep copying. You need to talk about inheritance. Without inheritance, you don't do that kind of stuff.
Thank you. And there's something else. We said there is no delete operator.
There is no.
Not assignment operator. I mean,
assignment operator doesn't do deep copying. Never.
Yeah. Okay. So there is no big tree, right?
No, there is no big three. No. There is no copy constructor. Okay, special copy constructor. There is no overloadable assignment operator. There is an assignment operator, but its meaning is fixed. You cannot change it. There is no destructor. We have something similar to destructor, but it is not destructor. That's why its name is finalize. There is a finalize method you can write, but it's not a destructor. And there is no, again, there is no big three. In Java, okay, in Java, if you have a class A, okay, like this, let's say public class. So let's look at this. What are the things that you can do with the objects of class A? When you say A, new A, okay, and let's say AB, another one. I could do this assignment, but this is not a really assignment of A objects. This is assignment of their references. Other than that, there is no ampersand operator. There is no, okay, the constructor is there, right? Constructor is there. And I mean, there is no, I mean, when I do the same thing, okay, so this is not, sorry. This is, I don't have it. So this is Java, and if I am writing the same class in C++, I will say that there is this default constructor, copy constructor, and the assignment operator is defined, and the ampersand operator is defined. None of them are defined for such a class in Java. So it is much simpler language to learn and use. What did I say? If you don't implement big three, if they are needed, then you are in trouble. You don't have that kind of troubles in Java. Of course, there are many other ways that you can go wrong with, but they are not similar to C++. And their number is much less. Again, it is simple language to use, less opportunities to make mistakes, okay? But in terms of flexibility, like writing an operating system, C and C++ are going to be better. But not everybody is writing operating systems, right? Very small fraction of all programmers, okay? But you are not going to be straightforward programmers. You are computer engineers, okay? You need to know the details of all the languages, details of the hardware. That's why you are taking all these courses. Of course, you need to be very good programmers. And plus, you need to know, okay, you are not like a car driver. I mean, driving a car is easy, but you need to know about the engine, and you need to know about the transmission and the suspension system and everything. So you become an engineer. Okay, good. So those were the good questions. Who asked those questions? Bahadur or Mehmet Avni? Who asked? Mehmet Avni asked the questions?
Yeah,
Okay, good. Thank you. So those are that's the kind of thinking that I like you to follow, okay? Try to compare Java and C++. That will make you both better programmers at Java and C++. And you will love your language even more, especially C++. Again, I mean, these kind of discussions are stupid discussions. Which one is better, Java or C++ or Python, okay? Whoever designed C++ or Java or Python, they were very, very smart people, okay? Definitely they were smarter than most of us, okay? 99% more smarter than 99% of us, okay? So they didn't make stupid decisions. Even they did make stupid decisions, they keep changing the language, remember? They added some stuff in C++ 98, then they deprecated in C++ 11 or 14, okay? So these languages keep changing. So if there is a decision, then it's a smart decision most of the time. And we shouldn't say that this language is better than the other language. So it is better in terms of what? I mean, it depends on what? I mean, you shouldn't say never learn something, never do something, okay? And there used to be some languages that were very good. Now people are not using it. That doesn't mean that those languages were bad languages. We don't need that kind of stuff anymore, okay? Let me tell you the best language that I know. The best language that is invented is the second language invented. It is Lisp. Okay, it is so simple. You could do anything you want. It can behave like a functional language. It can behave like a procedural language. It is object oriented. It is so simple. The syntax is so simple. Only a few things. Okay, I can tell you the syntax of Lisp in just 2 hours. That's it. And this was invented in 1959, 1960. Okay, so something like that, and this is the best high level language. But if you like the most flexible language, assembly is the most flexible language. You could do anything you like. Okay, so every language has its own pluses and minuses, and when the time change, you may switch from one language to another language. Okay, good. So let's move on. Let's move on. Gradebook test is here. Okay. Rest of the language features control statements, if else, ternary condition operator, switch, while they are all the same. Compound assignments are the same. Increment, decrement are almost the same. Break, continue have the same effect. Okay. Logical operators, yeah, these are there. But remember the single ampersand and single pipe, that meant bitwise and bitwise or in C++, right? In Java, we don't have bitwise operations. So what they do is they said that and or operators will do the short circuiting. Okay, this single ampersand and single pipe will do and logical and or, but it will not do short circuiting. They will always evaluate both sides of it. So there is a way to turn off short circuiting in Java. These are our primitive types: booleans, byte, short, character, integer, long, float, double. And their sizes are fixed. These sizes are defined. Their sizes are not machine dependent or operating system dependent. Float is always, I think it is 4 bytes. Double is 8 bytes. Long, I think it is 4 bytes again. Maybe 8 bytes, I don't remember. Okay, so these are all always the same size. Why can we say that? Because Java programs, they run on this virtual machine, Java virtual machine. Java virtual machine, okay, hides the details of the hardware from your program. Okay, your operating system, let me write it here. Java virtual machine here, your operating system is here, and your hardware is here. And your application program in Java runs on this Java virtual machine. Your hardware might support 64-bit integers, okay? And your operating system, okay, works on that. But Java virtual machine says that, okay, your integers are going to be 32-bit, okay, 4-byte integers. And it is the responsibility of Java virtual machine to translate all the 32-bit integers to 64-bit integers for you. That's why it's going to use some CPU time. Okay, so these are some fixed sized primitives. They don't change from machine to machine because we have only single machine. It is Java virtual machine. Good. Java has a very extensive library support. Okay, no include statements in Java. So what do we do if you like to use a class like this, you will say Java util and scanner. It's like the using declaration in C++. Java documentation, this company Sun, okay, this used to be a very big in its peak times, Sun was like Google, okay, in 1990s. Okay, Solaris operating system, which is a variant of Unix, was invented by Sun, and Java is invented by Sun. Okay, later, well, they were very early at when internet started booming, they were very good, but later they didn't do very well and they went away. So Oracle bought them, and Oracle bought all the Java stuff. Nowadays, all our official documentation is at Oracle sites. Okay, this one. And Oracle is a company that does stupid stuff. I don't know what Oracle. I think databases, right, and that kind of. So it is not a very. How should I say it? It doesn't do many inventions that are new, many contribution to the computer science, Oracle. So it's a very commercially oriented company. Sun wasn't like that, okay? They invented many stuff. Especially they contributed lots of stuff to the networking. Networking file system was their invention. Okay, so let's look at some of the. So I am not going to give any breaks, right, because I started late. Let's look at some of the packages. Packages are Java libraries. Applet package. Applet used to be big before. Applet is this. If you run your Java program like I did yesterday from this command line, it's a Java application, right? Let me see if I have. When I say Java, and I think it was the name hello. Where is my classes? Where are my classes? Welcome, yeah. When I say welcome, okay, it runs it. So I am running a Java application. Java applet is smaller than Java application, but they run on web browsers, okay? You make a Java applet, small Java application. You put it on your web server. If somebody loads up your page on their web browser, this application runs automatically on the web browser. That's called the applet. Nowadays, we don't use this much because it's a security risk, okay? Many people, many hackers, okay, they abused this Java applet stuff to hack into other people's computers. So people, they don't use this applet stuff. Abstract window toolkit package. It is used for graphical user interfaces, and we are going to use it. And this event is underneath this package, a sub package. It is used for processing events. What's an event? For a GUI, event for a GUI is like the keyboard key presses, mouse movements, or scroll bar activations, and etc. We will see it. This is for input-output stuff. Java language package, okay, is automatically imported to your program. You don't have to say import Java lang, okay. It is automatically imported, and it includes some basic stuff like string is defined in this Java lang. To be able to use this string class, okay, you don't have to import anything because it is automatically imported. Okay, what else? This is about networking, and this is about text processing. There are many utilities in here. For example, that scanner is underneath under this util package. Class string tokenizer is there. Random is there, okay. Sieving package and sieving event are the newer versions of AWT. Those are they are about graphical user interfaces. So we are gonna see many of them. Of course, I am not going to go into details of all the Java packages. There are so many. And each one is very detailed. And we are going to look at some of them at some detail, but not very detailed. So let's look at this scoping, shadowing, overloading. The ideas are same. The scoping of a scope. If you have a block like that, if you have an integer a, it will start living here and it will end its life here, right? Because its scope has ended. If you have, let's say, if you have I am trying to fix my pen. I think it's time to change my battery maybe. If you have a string s and you will say new string a, b, c, okay, and this is the end of the scope. When I hit the end of scope, a will die, s will die. When s dies, since nobody is referring to the string anymore, this will die too. Okay, so scoping is like that. Shadowing and overloading. Let's see an example actually. So I have a scope.java, and this is scope, and I have a private integer. And in Java, from the beginning, you may initialize your fields like that, like C++ 11. In C++ 11, we could do the same thing too. Okay. So this is my private field member, and this is a method, public method of this class scope. Inside the begin method, there is a local variable x, and on purpose their names are the same. So this x at line 13 is shadowing the field x at line 7. So remember, we are looking at scoping, shadowing, and overloading. So this is a shadowing example. Okay. When I print this out, system out printf, and local x in method begin as this. Okay, it is printing this one, of course, because there is, when I say x, it is this one, not that one. And it looks like I have a method, use local variable, then use field, use local variable, use field. Okay, and I am calling these two methods. Let's see what is happening with these methods. Use local, use field. It looks like in one of them I will have a local variable. The other one is going to use this one maybe. Okay, but this one, whatever you do, this one is definitely going to print 5 on the screen. Let's move on. And then how about this one? What would this print? Can anybody tell me what line 22 print? Since you don't know what use local variable and use field do, right? You may not know the answer, but no, you know the answer actually. What does line 22 print?
5.
It will print 5 definitely, because there is no way line 17, 18, 19, or 20 can change this local variable x, right? I didn't send any references, etc. There is no way they can change that value, so it's going to print 5. Let's look at this use local variable method. This use local variable says that I will have another x, my local variable, and this one will print, what does line 31 print? It will print 5, right? Then I will increment, no, it is not going to print 5, it's going to print 25 because x is 25, and I will increment this 25 by 1 and I will print it 26. So it doesn't matter how many times I call this method use local variable, it will always print 25 and 26. Okay? So it doesn't matter how many times I call it. The situation is not like that for use field method. When you call use field, it says that I am printing this value named x. What is x? X is not a local variable, but use field is part of this class. Class is scope class, and there is a field, integer field named x, okay, and its initial value is 1. So if the initial value is 1 for this one, it will print 1 at the beginning, then it will multiply x by 10, and it will print after that, it is 10, right? 1 and 10. But if I call it again, this time it will print 10 and 100. If I call it again, it will print 100 and 1000, etc. So depending on how many times you call it, it will print different stuff because it is modifying the field x. Okay? So this is really, the simple stuff. And we could have done exactly the same thing. We could have done exactly the same thing in C++. Okay, so this is the end of my class scope. Let's write another class, another file. Let's write another file to use this class scope. Okay, its file is scopetest.java. With the scope test, all I do is I make a new scope class object and I call begin. And if you remember, begin is like this. Begin, it has a 5 and it prints 5. Use local variable. Remember what we say about use local variable? We said that how many times you call it doesn't matter. It's going to be always 25, 26. So 25, 26. And use field is going to be depending on how many times you call. But the first time I call it, it's going to print 1 and 10. And use local variable again, 25, 26. Use field this time is going to print 10 and 100. And at the end, I will print 5 again. So that would be the output of this whole program. Local x, this is at the beginning. Okay, this 5 and this 5, it comes from the begin method. This is from use local variable 25, 26. This is from use field 1 and 10. Again, see, these are the same. And this 1 and 10, 1 and 10, this 1 and 10, they come from use field method. Okay, so as I said before, scoping, shadowing, overloading, they are very similar to C++. Any questions? Okay, if there are no questions, then I will continue. Arrays, okay. Somebody was asking about arrays. Arrays are kind of, there are similarities and there are differences between Java and C++. Similarities are there, okay. Arrays are arrays. When you say I have an array of 10, then that means that really you have a consecutive storage space for 10 elements. But arrays are basically reference types. They are like objects, right? They are like objects in Java. Since they are objects, they need to be created using the new operator. Okay, there's something new for you. Okay, if you like to make an array, you need to use the new operator. Okay, this one will create an array of size 12, and it's an integer array. Since it is created with new, I need to hold a reference to it, and this is how I hold it. C is a reference, and it's a reference to integer array. Okay, this line and these two lines are equivalent. First, here you declare a array variable, integer array reference. Then I use that reference to refer to this new integer array created on my heap again. By the way, this is not used anymore much, but the preferred way of saying that I have an integer array reference is this. Okay, integer array. Okay, you will say integer array. A is a reference to an integer array. Okay, good. So this one will create. So how is the memory now? Let me show you the memory. By the way, in Java they never draw this kind of stuff. They don't talk about memory. Okay, it is not appropriate to talk about memory for Java people. It's something that you don't talk about it. Okay, this is C. Okay, and I have a C is on the stack, but this array of size 12. This is size 12 of integers are in the heap. This is heap. This is stack. Okay, here. That's the picture. That's the picture. With the arrays, there is indexing operator. Okay. With the arrays, there is indexing operator. But other than the arrays, you don't use indexing operator anywhere. Only it is possible with arrays. Okay, what else? Array initializer can be used like C++, and multiple dimensional arrays are possible. But before going any further, let's look at a more detailed example. I mean, in this case, since I used a primitive type array, everything was even similar to C++. And you might say that, well, this is very similar to C++. I could see the difference, but this is very similar. That was similar because I used a primitive type as an array element. Let's use this. Let's see this. Let's say I have a gradebook array GA. Okay, GA is a reference to a gradebook array. Let me start drawing this memory configuration. So on my stack, I have this GA. Initially, it is null. It is not pointing to anywhere. When I say GA gets the value of a new, okay, a new gradebook array like this, okay, a new gradebook array of size 10. Okay, I will create a gradebook array of size 10. Okay, there are 10 elements in it, and GA is pointing to this. So, question, what is the type of each element in this array? What is the type of each element in this array?
Gradebook.
No, unfortunately, no, it is not. What is the type of each element in this array?
Gradebook reference.
Okay, each one is a gradebook reference. So, each one is a gradebook reference, just a reference. Okay? It's not an object. Remember, what was the only way to create an object in Java? New. Well, you might say that you use the new here, but I use the new for gradebook array. Okay? I didn't use new for the gradebook objects. So right after this one, if I say print line GA0 dot get course name, right after this one, if I say this, when I run this program, this line will crash. It will say that GA0 is a null pointer, null reference. It doesn't refer to anything. You don't have any objects on it. So this is a bad line. And sometimes the compilers are smart enough not to compile this code because it is seeing that this GA0 is not initialized at all. So each one is a null. Each one is a null here. So what are we going to do? This is what I am going to do, okay? This is what I am going to do. I will say in a for loop, I have my integer I from 0 to ga.length. Okay, in Java, arrays know their sizes. Okay, like the vector in C++. Arrays know their sizes, and their sizes are obtained using this length field. It is not a method, it's a field. And plus I. And then what am I going to write here? GA I gets the value of a new gradebook object, and I can say maybe just CSE241, or better yet, maybe I can do this CSE24, maybe 224. Come on, I am running out of patience. Okay, 24 plus I. This is a string catenation. Okay, this is a string catenation plus I, and yeah, okay, that's it. So I am running this constructor that takes the name, and that's it. After that, I could write this line. After that. Duplicate and put it in here. And this is okay now because there is something meaningful. So how is my memory? My memory is like that. My memory is going to be the GA0 points to a gradebook. Okay, gradebook object, GB object. Okay, and this GB object is pointing to what? A string in the memory that has CSE240, right? And this one is going to point to another object. Okay, gradebook object. And this one is going to point to another string, CSE241, etc. So each one is going to point to some other space in the memory. 10 of them. I will have 10 of them. Okay, so so this is very, in terms of usage, the idea is same, but in terms of usage, arrays are a little bit different in Java. The main difference comes from when you use arrays of objects. Okay, since the rule is this: you cannot have arrays of objects, but you can have arrays of object references. This is an array of object references, gradebook references. As I said before, you cannot create objects and name them. Okay, Java will never let you hold an object in your hand. Okay, you can only, Java always holds the objects itself, and it will let you hold references to those objects. That's how the language is designed, and this is the case again. You will never have arrays of objects, but you will always have arrays of references or arrays of primitive types like the double arrays or integer arrays. Okay, does this make sense? Does this make sense? And two-dimensional arrays are like, remember, we used the two-dimensional arrays in C, C++. They are like that, but each array element has to be initialized with a new array allocation. Maybe we'll see some examples of arrays later. Two-dimensional arrays later. Okay, in this slide set I have this stupid example. Okay, well, these examples, okay, as always with the stupid examples, example programs might be stupid, but they are very good for telling you stuff, okay, teaching you stuff. So overall idea is not stupid, of course, but the class itself by itself is stupid. Init array has a main method. Inside it I have 10 integers. Okay, and this one says that I am going to run this counter from 0 to array length, and it will print the counter and the array value. In this case, all the values are initialized to 0. That's how the Java initializes the array. All the primitive types are initialized to 0. Doubles are 0.0. Integers are 0. Longs are 0. All the booleans are false. Okay. And all the references are null. Okay, good. And if I continue, range base 4, remember in C++ 11, Java has this enhanced for statement. You say parameter and the array name. Okay, you say parameter and the array name. That's it. So remember this code. If I like, I would say for Gradebook GB GA print line, system out print line, actually system out print line, and then GB. Okay. You might ask, how does print line know how to write a gradebook object on the screen, right? In C++, we achieve this by overloading the stream insertion operator. In Java, we don't have operator overloading. How does print line know how to print a gradebook object on the screen? Okay. How does it know? Okay. In Java, all the objects know how to convert them to strings. Gradebook objects, they know how to convert itself to a string. Okay. And the default behavior of this string conversion is not something nice. We always change it, and we are going to see it later. Okay. So maybe this is a surprise, because when I say all the Java objects know how to convert themselves to strings, that means that I kind of lied to you when I say if I have a Java class A, and I said that there is not much about this other than the default constructor. We don't have the present effect. But then you might say, so where is this behavior coming from? Okay. How come a Java object knows how to convert itself to a string? Then there is some part of this class that I am not telling you, right? That's true. And I will tell you later. There are some things that these class objects can do by default. One of them is these class objects know how to convert themselves to strings. Okay, so this will work. This enhanced for statement will work. While I am talking about arrays, let's write a method. Let's say some part of a class, since I cannot write global methods, right? Some part of a class, let's say I have a method. Let me write this method down there. Void void method1, and I am going to send a gradebook array to this method1. So what would be my parameter for this method? What would be the parameter for this method?
Gradebook index. Yeah.
Yes, exactly. Gradebook and parameter array. I don't take the sizes. Okay? I don't take the sizes because Java arrays know their sizes. Java arrays know their sizes. And what is this going to do? This is going to do maybe for gradebook GBRPA, maybe I will just use system out print. No, I'm not going to do that. No, I will just do this. GBR dot print message. Okay, so This will call the print message method of all the objects. Whatever print message does, it will be printed on the screen, I guess. That's what it does. Can I do this? Can I do this? GBR dot set course name. I don't know, it just deleted some other text, and that's it. Can I do this? Can I modify the elements of an array? Yes, I could, right? Yes, I could, of course, no problem. Because I have the references of it, and I can call any function, any method that I like on the elements of this array, GBR, right? I could do that. I could do that, no problem. I am calling it. Or if I like, I could do this. PA0 is new gradebook math 101. And if I like, I could do this. That would change my first element of the array, right? Remember, this is a reference to an array. This is a reference to an array. Okay? Using that reference, I follow the reference and I change it. No problem. So when after I call this method M1 with GA, okay, it will print all the gradebook objects on the screen, and it will set their names to delete it, and then I will change my first object, the first element in the array, to a new gradebook. What's going to happen to the old gradebook in that position? It will be automatically deleted because nobody is referring to it anymore. Okay? Good. How about this one? Question for you. Void M2. Again, a gradebook reference, a gradebook array, and again, it's, let's say, parameter array. I am doing this. PA gets new gradebook array of size 5, and I just return, and I call M2 GA. And after that, I will just call GA1 dot print message. So this part of the code is different. So when what would happen when I call M2?
I think it will give error.
Mehmet, I got some static. Just repeat it again.
I think it will give error.
Where is the error?
In GA1.
Yeah. Why? So you think that my GA will be replaced by this new gradebook array, right? All GA will go away, and the new GA will hold all null references. That's what you are saying.
Yes.
Any other ideas? Any other guesses?
The M2 will not change, will not modify, cannot modify reference of PA.
Yes, exactly. I mean, this is different than that one. This one is definitely modify. Okay. This one is definitely modify. Okay, let me do this. GA. Where does this come from? Okay, okay. GA0 dot parent message. This line here will print math 101. Why? Because M1, after doing all that stuff, changed PA0 to a new gradebook object. So this one will print math 101. I know that. But when I do this with M2 takes this PA, but again, this PA is a copy of GA. PA and GA are just simple references. They are not whole arrays, okay? I'm not sending the whole array. This is like sending an array to a CF function. PA and GA are references. And PA is a copy of GA. In both cases, in M1 and M2. When you modify PA, you are modifying this copy. So this one will get a new array of gradebook. And this PA is pointing to this gradebook array. But GA is pointing to its original array again. Okay, when I make this call, both PA and GA are pointing to the same array of size 10. But now PA is pointing to a new array. But GA keeps pointing to my old array. When this method ends, PA is a local reference. It will die. When it dies, nobody is pointing to this array anymore. This array is going to die too. Okay. When I come back, GA did not get modified, and GA1 is going to print its message. No problems. So Mehmet Hussein, that was a good guess, but that wasn't right. Okay, so this is a good example to show how the arrays work, how the references work, and try this yourself. Write it and try to understand what's going on with this array stuff.
But what about content of PA?
What about the content of PA here? You mean M2?
Not M1, in M1.
M1 here, okay. Well, in that case, again, I am following the pointer, okay? I am modifying. Again, this PA is both PA and GA are references to. I have drawn this the figure before for PA and for GA, but I'm going to draw it again. GA is something like this. GA is my pen is okay, here it is. This is GA. GA is pointing to an array of size 10. There are 10 elements. Now I have my PA in M2, Okay, at the beginning, PA and GA are pointing to the same element, but now when I execute this line, now PA is going to point to a new position of size 5, and this arrow will go away. Okay, now this is the picture at the end of this function execution. But then when this method ends, PA will go away. When PA goes away, okay, when PA goes away, nobody is referring to this. This will go away. Okay, so let's look at M1. What's going on with M1? Let me draw it like that. When I call M1, I will have another PA. This PA is going to point to that memory location, right? Since I am not modifying PA, all the things that I am doing will be on this array. Okay? So I am saying that run this loop. For each element on this array, call the print message method, then set course name to deleted. So I will modify all the objects pointed to by these elements of this array. And at the end, I am saying that just the first element now is going to point to a new gradebook object that contains math 101.
Thank you. It's more clear now.
Okay. Good. Try it yourself. It is not complicated, but you need to remember that all the array stuff in Java are references. Okay. And by references, I mean they are really like C pointers. Okay. All the arrays are in C. All the arrays are pointers, right? And in Java, all the arrays are references, and each one is pointing to a reference array if they are referring to some objects. If they are referring to primitive arrays, then the arrays themselves hold the primitive elements like doubles and integers. But in Java, there is no array of objects. There is always array of references or array of primitive types.
Is there any way to allocate memory for J through a function?
Is there any way to allocate memory for what again?
For GA.
For GA. What GA is a name for an array, right?
Yes.
So how can I create memory for GA?
Like.
Oh, you mean resize it?
Yes.
Oh,
in
no.
M2.
There is no shrinking or expansion of arrays in Java, like in C. You cannot add new element at the end of GA. There is no way to do that. All you can do is allocate some new memory of larger size, then copy the old values to the new position. So how about pushback? Can I have a pushback for arrays? No, but there are other standard classes in Java that offer methods like pushback. One of the classes are array lists. Array list. Class array list behaves very much like vector array list. You may add stuff at the end of the array list using the add method. And we are going to look at this Java collections hierarchy later, but Java class array list. Okay. It's a generic class. Generic means templated. okay, and it has many methods like add, okay, appends the specified element to the end of the list, add another, add all, clear, clone, and we are gonna see contains, etc. So this behaves like really like the vector, but you will never see, okay, you will never see the index operator. And when I make this search, okay, when I make this search in okay, I see 7 occurrences of this index operator. They are all parameters of some kind of an array, okay? So you will never see an index operator for any of the Java classes, because index operators are only valid for the Java arrays, okay? And that's the part of the syntax of the Java. You cannot overload the meaning of the index operator in any way. So all these library classes, they can only say, give me this element. I think they are using this get. Where is this? The indexing is done with the array get. Yeah, get will return you the element at index. Okay. Good. We talked about these arrays a lot, but that's a good thing. I'm trying to teach you both the arrays and the references. Enhance for statement, we talked about it, and here is an enhance for statement. Remember what we said before? We said that you may use the initializer syntax. You may use the initializer syntax to initialize the arrays. Okay, here is an array. When you read line 8, maybe some of you thought about a small lie that I told you. I am sorry. When I said there is no way to create objects in C++ other than the new operator. But line 8 says that I don't see any new operators here, but you are creating an object. That's right. Okay. There are a few exceptions. Okay, there are a few exceptions. Like the array initialization is one of them. You are creating an array without using any operator. Also, similarly, when you say string as A, B, C, again, I am creating a string without using the new operator. These are some exceptions. But these exceptions only happen with your standard classes. See, string is a standard class. Array is part of the language itself. Okay, so this is my array. Total is 0. And I am running this enhance for statement. Number array. Total is added always with this number. And at the end, I will print out the total of this array, whatever it is. Okay, nice, good. Always try to use enhance for statement if you can, because enhance for statement will handle all the initialization of the index and iterating through all the array elements one by one, and that will be more efficient than the code that you write, because the code you write is going to be complicated for Java virtual machine, incrementing that index, okay, and checking against the end of the array and etc. They all have to run through Java virtual machine, and Java virtual machine is inefficient. But if you write it that way, okay, there are very good assembly optimizations for these kind of statements under the Java virtual machine. So these kind of loops can be as fast as C code. Good. Any questions? No questions. Continue in that case. Passing data to methods. Okay, we know call by value, pass by value, and pass by reference. In C++, we have only, we have both call by value and call by reference, right? Pass by value and pass by reference. In C, we have only pass by value. That's true, right? In C, we have only pass by value. We don't have any pass by references in C, but we have our simulated pass by value using our pointer stuff. Okay, but in C++, they have invented this R value references and L value references. Remember that one? In C++, when you say, I have an integer I, this is pass by value. But when you say, I need an integer reference, this is pass by reference in C++. We don't have this in C. Okay. Java behaves exactly like C. Java is like C. There are no pass by references. All you can do is methods. The method can take an integer. So when this method takes this integer, it makes a copy of it. Or method can take a reference, gradebook reference. So this is like a pointer. Again, I am making a copy of a reference here. So call by value again, call by reference, call by pass by value. In Java, when they teach small children about pass by value, pass by reference, they say that we have pass by value for the primitives, pass by reference for the object types. But in fact, the true thing is that the correct thing here is everything is by pass by value, exactly like C. Okay. So whenever you pass something to a method, a copy is made. If you are passing a basic type, okay, like integer double, you make a copy of it. If you are passing a reference, you make a copy of that reference. That's why here PA is a copy of GA. That's what I said. PA is a copy of GA. If you modify PA, GA is not going to change. But if you modify something that PA points to, okay, GA will be affected, of course. So that's the idea. That's the idea. So this slide is kind of not correct. There are no pass by references in Java. Like in C, we don't have call by references, pass by references in C. All we can do is we pass our pointers and the function makes a copy of that pointer. But if the function follows that pointer, it can make any changes on those objects, not on the pointer, but on the objects. Okay, good. Any questions on this? Any questions? You might say that, what if I want to send an object to a function, to a method? No, you cannot send an object to a method in Java. All you can do is you can send a reference of that object to a method. Okay, because you cannot hold the objects in your hand in Java. At most, you can hold a reference to that object. So what you're gonna do, you can send only the reference of that object to a method. Good. I think I will skip this one. Command line arguments. We don't have any return values from main methods in Java, but command line arguments are there. So how am I going to pass my command line argument to a Java program? You will say Java virtual machine, my class is my program, A and B are my command line arguments. Remember my Java method, string args. So that means that I have a string array. Let's look at this program and let's end the lecture after looking at this program. This one says that, let me show you the output first and let's come to that one, okay. The name of the program is init array, Java initialization of array maybe, Java init array. When you say Java init array, okay, error is please re-enter the entire command including the error size, initial value and increment. So my program printed out an error message, says that, okay, print the error size. Okay, I need to give me the size of the array this initial value and the increment value. So I use it this way. Java unit array 504. I need an array of size 5. Okay. The values of the array will start from 0, and each time you make an assignment, increment it by 4. So the index number 0 is going to have the value of 0. Index number 1 is going to have a value of 4. Index number 2 is going to have a value of 8, and index number 4, etc. Okay. So it initializes an array like that. And if I run this program again with the values 10, 1, and 2, the array will have a size of 10. The first value will have 2. Then I will increment each time by 2. 1, 2, 1, 3, 5, 7, etc. Okay. So if the user doesn't provide the correct number of parameters, then I am going to print out this error message. Okay. Let's see the program. The program is like this. My main method will take an array of strings. If the array length is not 3, okay, this is kind of, remember in C, the number of arguments is usually one more because the number of arguments include the program itself too. So this one says that if my length is not 3, if the user did not provide 3 numbers like 10, 7, 5, okay, then I am going to print out this error message. Okay. So if I have 3 elements in this array, string array, let's see what I am going to do. Line 16. First, the length of the array. What is my length of the array? It is going to be the first string, but it's a string. It is not an integer, so I need to convert it to an integer. In Java, this is how you convert from a string to integer. There is a class named integer. The name of the class is integer with a capital I. We will talk about this later. Every primitive class in Java has a boxed version. The boxed version of integer is integer. For double, there is double. Okay. For Boolean, there is Boolean. So if the first character is a capitalized, then you use the same thing. So integer class has a static method that converts a given string to an integer. Okay. So what is the corresponding line in C? What is the corresponding line? What is the corresponding statement in C for line 16? What would you write in C to convert a string to an integer? What function would you use? A to I, right? Alphanumeric to integer, A to I. Since in C we have all global functions, I can call them, but in Java there are no global functions, but we have static methods, integer class and static method. So I have the array length. Now I create my array of size array length. Like in C, okay, we don't have, in C we say that you cannot create an array with a changing size. The size of the arrays should be fixed. If you like a dynamic array, then you need to use the dynamic memory. Well, I'm using dynamic memory here too. Okay, an integer array of size array length created with new operator, and now my array is pointing to it, referring to it. I created an array, and I have my initial value, the first argument, increment value, the second argument. I will run this loop from 0 to array length, and array counter is going to get the initial value plus increment times counter. Okay, And after that, I have this initialization. Now I am going to print out the index and the value. Okay. And this is from 0 to length, printf counter and array counter. And that's it. So this is a stupid example again that uses the command line arguments. A little bit simpler than what we used to do with C and C++. Because with C and C++, it was an array of characters plus the size of the arguments. Now we have an array, and that array knows the size itself. Okay, I'm way out of my time. I will stop here, and Monday morning we will continue from this point. Any questions? Any questions? Okay, if there are no questions, which I don't like, you are asking too few questions, way too few questions. Okay, I mean, I expect many questions because these are new stuff. Some of them are shocking, some of them are confusing. If you don't ask me questions, I don't know how I can help you. Okay, just study hard during the weekend and try to understand what I am saying here, and try to write Java programs. You know how to write Java programs, right? Use your favorite editor, write stuff, and compile it and run it. Okay, I'll see you on Monday morning then.